submodularity in ranking, summarization, and self-attention. Using diminishing returns to optimize results under a budget constraint in problems of coverage and result diversification. Let's say we have sentences. We have a sentence S1, S2, S4, and so on, and those sentences are similar together. For example, they may be similar if they have important words, if they contain the same important words. So how would you create a summary of this kind of set of sentences? Well, you would select sentences that are sort of central to the text, that they, in a way, they are close to to all sentences in the document, but those ideally would be far away from each other, because you don't want to cover the same topics multiple times. So if you're going to summarize this, you are making a trade-off between selecting central sentences and sentences that are themselves different from each other. So this idea can be modeled using a diminishing return principle, using a submodular function. Submodular function is a set function whose value has a property that the difference in incremental value the function has by adding a single element decreases as we apply the function to bigger and bigger sets. So more formally, if we have a function S1, if we have a set S1 and S2, S1 is a subset of S2, and we look at the difference when I add of the function value, when I add the element into the S1 as compared to when I add the element to the set S2, then I get a bigger increment from adding this element when I add it to a smaller set. That sort of diminishing return idea, right? We know this, we encounter this property during shopping in form of a quality discount. The discount of addition of one more item to the purchase cart decreases with the size of the cart. This principle is called diminishing returns. For example, the price per product as a function of a set of purchased products S could be dependent on the product count. And for example, it could have following form. So the price would be exponential minus number of elements in a set. So the price sort of decreases per product as the set increases. And if you look at the two different sets, right, each product is different. Anytime we add the product to set, all the products are different in this scenario. And if we look at the difference in the price, we'll find out that indeed with the larger cart, the increment of adding one more product is less. So this is a submodular function in this scenario, this exponential minus size s. Submodular functions appear also in maximization problems where they model notion of diversity, information, and coverage. For example, we would like to have this document summary. As I mentioned, we want to cover all important topic, all relevant concepts in the document, and at the same time we would like to avoid topic repetition. We don't want to repeat all the same sentences, even though we know those are important sentences. So we want to diversify a little bit. So this is another place where we find submodular functions. But here we have also this concept of a budget. We are summarizing and we would like to limit the number of sentences in the summary. Submodular functions have interesting mathematical properties. If we minimize them, there is a polynomial algorithm for finding a minimal set. For non-negative submodular functions, maximum set, finding a maximum under the budget constraint is only approximable, but with in polynomial time, but with a greedy algorithm, so it's fairly fast, and this is what we are going to use for the summarization soon. Submodular functions have a nice property in that they can be combined. For example, I think they are linear under some additional requirements and so on. So this is also used further down in the text. So there is this concept of maximum marginal relevance, which is used to re-rank for diversity of query results. So the goal is here to trade off redundancy of the query results for small decrease in relevance of the results. It's a little bit like the summarization, right? So again, I'm searching for something. I enter my key phrases, my keywords, and I get the results. But I don't want to see, for example, the same domain name 10 times. 10 pages from same domain name. For example, if I search Apple, I don't want to see, million pages about Apple computers. I want to see something about Apple computers. Then I would like to see something about Wikipedia, about Apple nutritional quality, and so on and so on. I want some diversity. So how can we do this? There's actually a very simple way how to do this. Let's say we have a set of documents V and a subset of documents that we've already selected for the results. And then we have some kind of mixing constant lambda between 0 and 1. So the next document we select by following way. So we do argument, we look for maximum of such documents that we haven't yet selected, and we look for maximum of following value first. We want this new document to be relevant, to be similar to the query, but at the same time we are subtracting the 1 minus lambda times maximum similarity to other documents. So when we are selecting, when we are doing this maximum, we are having this trade-off constant, which makes sure that we put enough weight on one of those two factors. Is this document relevant? And at the same time, is it dissimilar to the documents that we already have in the results? So the first part of the equation grows with the document similarity with the query, and second part decreases with the document similarity with the already selected documents. Alright, so this was for queries, and we haven't seen any submodularity yet, right? So we will see it now. Do you have an idea how we could actually use it? Where is this diminishing return? Do you see it? Do you see it yet? Well, so let's go. Multi-document summarization via budgeted maximization of submodular function is a paper that formulates summarization as a problem of maximizing a submodular function under a budget constraint, where V is again set of all sentences in the document, but we want to summarize, we want to select a subset. But at the same time, each sentence has a cost of adding it to the summary. For example, it could be word count in the sentence. And what is this modular function f? Well, we don't know yet. I will show you soon. But there is this budget. Yeah, as I mentioned, there's a cost per sentence. For example, maximum number of words in the summary, right? So we are doing this. We are looking for maximum set of these sentences such that we maximize some kind of function, a submodule, and we have this budget constraint. As mentioned previously, this will be approximable. But exactly, what is the function? So the function in this multi-document summarization, we have budgeted maximization of submodular functions. They suggest a submodular similarity function, which is constructed in the following way. So we are summing here over documents that were not yet selected and then over documents that were selected. And we are summing similarity between those that were selected and those that weren't. So this is the first part, and then there is the second part where we do lambda times sum over already selected documents and their inner similarity. Right, so this is not exactly transparent, but hold on, we will actually simplify this. And if we can look at this just shortly, so the first part grows as the selected sentences become similar to all sentences in the V. So it is kind of a little bit like we had before, right? So the first part is where we get this, how good are our selected sentences, how good they summarize all of the sentences. And the second part decreases as the selected sentences become more similar between each other. So this is the part we don't really want. So how do they solve this, and what is the selection of those documents? Well, they actually present a greedy algorithm that is that have some kind of near optimality guarantee. It means that we are going to get close to optimal solution. And the algorithm simply repeatedly finds documents maximizing following way. Again, they are maximizing, if I add a new document, I want to maximize the increment of this function, right? This function. So I want to have, if I add a new document, will this document, increase this rank that I have? This sort of, will it increase my perspective on this summary? Okay, kind of makes sense, right? Details can be found in the paper. But how is this really similar to maximum marginal relevance? Is there any similarity? Actually, if you rewrite this, there is a proof over here, you will find out that you can break the difference of adding one document into two following values that are fairly similar to what maximum marginal relevance had. So what are those parts? So the first part grows with the sentence similarity, with the sentence that is being added, similarity to all other sentences in the document. So this sort of tells me, okay, how well this document ranks that I'm adding, how good to rank, because how central is this sentence? Do I want to select this sentence? And then a second part actually decreases with the sentence similarity to already selected sentences. So is this sentence telling me something new that wasn't in the summary just yet? And by finding max of these two, similar as in maximum marginal relevance, I can find good results. And actually, if they did this with EDF modified cosine similarity matrix, they achieved state of the art at the time. They outperformed PageRank based centrality summarization and also algorithm. Basically, that's an algorithm called LexRank. And to be fair, the LexRank actually had used similar principle, but they used this maximum marginal relevance as a sort of re-ranker. So with this approach of a submodularity, they were able to beat this maximum marginal relevance. And it seems that the principal ideas in this paper were what made them, would help them significantly. Okay, where else can we use these ideas? For example, in Wiki term disambiguation, you have these, you do search on Wikipedia, you get, random matches over it, but you would like to sort of say, all right, for this word, actually it could be this word in the Apple can be computer company, and so that's in the industry section, and it can also be in the fruit section and so on. So I have many of these documents. I would like to create just a litter tree of these documents and just have some relevant names for this litter for the documents in this litter tree. I would like to say, okay, in the industry, Apple can mean this computer company, but it can also mean this company in Japan or something like that, right? And you want these nice hierarchies. But the issue is that the hierarchy is too big. How do we select these just nice, descriptive topics into which the documents can fall into? So the way they solved it in this paper in 2015 was that they written rules that had submodularity property. They combined them using linear combination, and they were able to actually generate nice disambiguations. Nice application. And okay, what about the modern world? Can we use this? Is there something in the transformer architecture where the submodularity could be used? Can you think of something? Well, there is this attention, right? The self-attention when we are decoding, when we are doing a summarization, we are basically taking as an input states of previous decoder states, and they are paying attention to the encoded input. And while we are paying attention, we are generating this softmax positive value. And we can look at these values, and we can look at the attentions at the individual tokens, and we can say, all right, we would like to apply diminishing property here. So we'd like to, if we are focusing on one token, we'd like to cover it once in the summary, but not much more. We'd like to have diminishing returns. Similar as in the previously, where we wanted to select sentences that were highly central, they were summarizing the text well, but at the same time they were dissimilar. So here we'd like to decode the text into summarization, but pay attention just to the couple of just to each token just once. So there was this paper. They implemented a solution. I will not go too deep onto it. Basically, they applied their submodular function was a summary of states of attention on the given token during a decoding step, and they were able to improve the summarization performance. They slightly outperformed transformer models, one BART model and one pointer generator model. All right, so that's all from me. I hope you liked. I hope you got this idea of submodularity, the idea of diminishing returns with the budget constraint. And if you'd like to meet other people, other machine learning enthusiasts in one-on-one online calls regularly each week, you can join this machine learning crew at Random Meets. At Random Meets, this little tool are created, so you can try it. And yeah, of course, you can subscribe and leave some comments if you have questions. Check the blog as well. Okay, see you.